Hello dear students, how are you all? I hope you all are healthy and doing well. So students, I'm your mathematics educator and from today onwards, I will be taking your mathematics classes. Today we have chapter number 1 which is knowing your numbers. So today we are going to learn about the numbers in detail. Let's get started. Introduction. Consider the problem of counting the numbers of members of a collection. What we do is use the same set of words and the same set of symbols to describe the numbers of members of any kind of collection. Whether we have a collection of houses, a collection of people, or a collection of books, we use the words 1, 2, 3, and so on to state the number of members of a collection. So, what we see here for counting anything, it's kind of your houses, your buildings, your group of children, what we have to do, we repeat the same number of counting because we have same 1 2 3 4 to count them. Natural numbers have their origin in counting numbers, which are the most familiar numbers, but a number is only an abstract idea used in counting and measuring. A symbol which represents a number, it's called numeral. Okay, the number system that we use nowadays is known as Hindu-Arabic system. Which kind of system we are using nowadays? Hindu-Arabic system. Two great Indian mathematicians could be given credit for developing Hindu-Arabic numerals. The first one, Aryabhatta, who gave the concept of place value, and Brahmagupta, who introduced the symbol 0. The simplicity of these numerals is a result of the brilliant invention of the concept of place value. Use of numerals enabled development of systems for recording large numbers. In addition to their use in counting and measuring, numerals are often used for tables, telephone numbers, for ordering. So what we see here and what we get by reading this, that today's, first of all, the symbol we are giving for numbers, that is called your numerals. The number represented by a particular number, that is called your numeral. After this, what kind of number mathematics number system we are using nowadays? We are using Hindu-Arabic number system. Okay, the second, this Hindu-Arabic system is originated by Aryabhatta, who originate the concept of place value, and Brahmagupta, who invented the symbol of 0. So these two great mathematicians we have in Indian, ancient Indian, and Hindu-Arabic system is originated by them. Now we using these numbers for our day-to-day life, for example, for ordering, for telephone numbers. If I want to ask you what is your telephone number, so you could be say 989464, anything you say to the your mobile number would be included all the numerals, not any alphabet. So this is the concept we learn in this section. You are already familiar with addition, subtraction, multiplication, division, and ordering of numbers. Here in this chapter you will learn more about numbers. So we already know about our 4 basic operations we are using with numbers to calculate anything. What are those basic concepts and operations? We have the first addition, then subtraction, multiplication, division. Let's get started in further. Let's get move forward. Natural numbers and whole numbers, as stated above, a symbol which represents a number, it's called a numeral. Numerals differ from numbers just as words differ from the things they refer to. The symbol 11 and 11 are different numerals representing the same number. So this is your Hindu-Arabic system and this is your Roman system, which we already learnt in our earlier classes. So the numerals which are used in counting objects 1, 2, 3, 4 are called natural numbers. It means when we have a smallest number 1 is our natural number. Whichever large numbers you may think of, you can always find a number larger than it. Thus, there is no largest natural number. The number 0 together with the collection of natural numbers give the collection of number 0, 1, 2, 3 called the whole number. So, this is your basic. Natural numbers means when you start your counting from 1. Whole number means when you start your counting from 0. There is no ending of natural numbers and whole numbers. You just have to keep in your mind the starting initial point in natural number 1 and in whole number 0. And the only difference between natural number and whole number is this: whole number we have 0, or in natural number we don't have 0. Otherwise, all the numbers will remain same in both the categories. You can see that every natural number is a whole number, but there is a whole number 0 which is not a natural number. 0 is the smallest whole number. Our number system, Hindu-Arabic system, uses 10 symbols or 10 or numerals. So we have 10 symbols, or we can say numerals. 0 to 9 to write a numeral for any number. Each of these symbols is called digit. For example, 215 and has 3 digits, 2, 1 and 5. 1948 has 4 digits, 1948. So what we examine here, that we have total 9 numbers 0 to, we have 10 numbers, 10 symbols 0 to 9, and by repetition of this number we make different numbers. Okay, so now comparison of numbers. Two cases arises depending upon the numbers of digits the two numbers have. Case when the two numbers have different number of digits, comparison is pretty simple here. The number with less digit is less than the number with more digits. For instance, if you have a 3-digit number and a 2-digit number, then the 3-digit number is greater. The two numbers have the same number of digits. If the number of digits in the given number is same, we start comparing the digits at the leftmost place. So here we have two kind of cases when we have to compare the numbers. First of all, you have to compare according to their digits. Which number have more digit, that will be greater. But in suppose case you have both, in your both numbers you have equal number of digits, that then you have to compare your numbers from the leftmost place. So let's do some examples. Compare 987 and 1250, 1256. So first of all, in this we have more number of digit, that according to this your 1256 is greater. Compare 36,952 and 37,108. So in both the numbers we have equal number of digits. Then we have to compare the first number. So now your 6 and 7, this 6 and 7. So in that case your 7 will be greater as compared to 6. So this number is bigger. I hope so students this comparison is it's clear to you. Filling the blanks is to make the following statement true. Dash is the smallest natural number. 1. There is a largest whole number. Largest whole number will be your 9. Okay, the smallest whole number is 0. For 9 we cannot say largest, there is dash largest whole number. इसको रहने देते हैं. Next we have the smallest whole number is 0, a number with more digit dash than a number with the less digit. A number with more digit, it's greater than a number with less digit. Rest of the two blanks you have to solve it your own. Compare the following pairs of numbers. So first we have to see how many digits we have. In this we have 4 and in this we have 5. So in this case this one is greater. Okay. Now 23,510, again in this we have more digit, that's why this one is greater. In this we have equal number of digits. 729 is 720 is common, 720 is common. 9 and 1, which one is greater? 9 is greater, that's why this number is greater as compared to 149. Arrange the following numbers in ascending order. Ascending means when we arrange our numbers from smaller to larger. So 9. First you have smaller digits 1, 2, 3, 4. Okay. So 1 we have this, then 2 we have this. After 2, 1, 2, 3, 4, 5. So at the place of 5 we have this 1, 2, 3, 4, 5. Then first we have 1, 5, 6, 7. After this 9, 8, 3, 0. After this we have 1, 1, 2, 6, 5. Then 91024 and then 749103. So same process you have to do for part B, or you can arrange simply. Now arrange the following numbers in descending order. Now you have to arrange the following numbers in descending order. So same process you have to repeat here. The slightly difference is this. In descending order we are arranging our numbers from bigger to smaller. So it would be your, the bigger number we have 45,059, 4,51,000, 4,51,000, 5,98,000, 98,345, and 1,94,000, 49,000. So first of all we have 5, 9, 8, 3, 1, 4. According to digits in this we have 5. After this we have 4, 5, 1, 3, 8, 9. Then we have 1, 9, 4, 8, 5, 3. 10, 9, 8, 3, 4, 5, and then 4, 9, 5, 8, 3. So this is your arrangement in descending order. Now next question you have to do it your own. Next concept we have place value and face value. A numeral representing any number is made up of digits. Each digit in a numeral has a value depending upon its position. This value is called place value of a digit. For example, in the number 547, the digit of 5 is in the 100 place. So its place value is 5 multiplied by 100, 500. The digit 4 is in its tens place. So 4 multiplied by 10, 40. 7 in its ones place. So 7 multiplied by 1 is 7. So I hope so it is clear to you how can you calculate the place value of any number. Now we have, there is no other value that a digit has that of a number that is represented. It is called the face value of a digit. Face value of a digit is irrespective of position of the digit. In the above example, place value of 3 digits 5, 4 and 7 are 5, 4, 7 and they will be the same in any number. So place value you have to first identify the face, and then in place value first you have to identify the place and then multiply a number with it and you will get your place value. But in face value the number is exactly the same as the number we have. So 5 face value is same 5, 4 face value is 4, same. Okay, next we have system of numeration. The method of expressing numbers in words, it's called numeration. A number can be represented by Indian system of numeration or international system of numeration. Place value charts for both the systems are shown below. So this is your place value in Indian system, where we have ones, tens, 100, 1000, 10,000, lakhs, 10 lakhs, crores, 10 crores, arabs and 10 arabs. Now in figures we can also represent same 1, tens, 100, 1000, 10,000, 1 lakh, 10 lakh, crore, 10 crore, 1 arab and 10 Arab. In order to read the numbers in the Indian system of numeration, the place values are grouped in periods: ones, thousand, lakhs, crores, and Arab. One period consists of the first 3 digits starting from the right of a number, the next 2 digits from the thousand period, the next 2 digits from the lakhs period, and the next 2 make the crore period, and the next 2 make the Arabs period. While reading a number, all the digits in the same period are read together and the name of the period except one is read along with them. For example, the number is, first we have to count 1, 2, 3, 4, 5, 6. So 17,43,892 is read as 17,43,892. While writing large numbers, commas are inserted after each period so that the digit in a period are easily recognized. For example, the number this is written as 68 crore 12 lakh 70,560. Okay students, now we have international system. International system we have ones, tens, hundreds. After hundreds we have thousand and 10,000. Similar we have in our Indian system. But after 10,000 we have 100,000. Then million, 10 million, 100 million. Billion, 10 billion, 100 billion. Trillion, 10 trillion, 100 trillion. So in the basic difference between Indian system and international system is 100 million, 100,000. In our Indian system we don't have 100,000, but international system we have it. Now in order to read numbers in international system of numeration, the place value are grouped into periods: ones, thousands, millions, billions and trillions. The ones period is made up of the first 3 digits from the right of a number, the next 3 digits from the thousand period, the next 3 make the millions period, and the next 3 constitute the billions period, and the next 3 form the trillions period. While reading a number, all the digits in the same period are read together and the name of the period except once is read with them. As in the Indian system of numeration, commas are inserted after each period. For example, the number this is written as 5 billion. Okay, 5 billion 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 billion 900, 1,652,803 is the correct way to read it into international number system. Now we have our expanded form. Recall that expanded form of a number is the number expressed as the sum of place values of its digit. For example, to write the numbers 3 crore 28 lakh 59,764. Now how we can write it? First 1, 2, 3, 4, 5, 6, 7. 3 multiplied by 1 crore, 2 multiplied by 10 lakh, 8 multiplied by 1 lakh, wait, 3 multiply by this, 2 multiply by 1 lakh, 8 multiply by 1 lakh, 5 multiply by 10,000, 9 multiply by 1,000, 7 multiply by 100, 6 multiply by 10, and this. So ones, tens, 100, 1,000, 10,000. After 10,000 we have 1 lakh, 10 lakh. After 10 lakh we have 1 crore. So this is your 10 lakh. So write the two places of 4 in the write the two places values of 4 in the number of this. So we have to write the places of 4 only. So ones and tens. So first is 40, tens, 100, 1,000, 10,000, 1 lakh. So 4 multiplied by 1 lakh is 4 lakh. So the two place values of 4 are 40 and 4 lakh. Write the place value and the place value of each digit in the number this. So 9, we start from left most. So 9 we have place value 9. 8 we have 80, then we have 300, 4,000, 60,000, 5 lakh, and after 5 lakh we have 1, 2, 3, 4, 5, 6. So 10 lakh. Insert commas in the correct position and write the numbers for this. So Indian system of numeration and international system of numeration. This is a number. So ones, tens, 100. After 100, 1,000, 10,000, 1 lakh, 10 lakh, and crore. So this would be your 4 crore, 2 lakh, 4 crore, 2 lakh, 54,698. Okay. 4 crore, 2 lakh, 54,698. Now in international system of numeration would be, in this we have 40 million. Ones, tens, 100. After 100 we have 1,000, 10,000, and 10,000 after 100,000, 100,000, then 1 million, and then 4. So 40 million 254,698 is your answer. Write the numeral 545 million, 545 million, 23,502, 37 crore, 37 crore, 9 lakh, 16,891. Now write the numeral corresponding to this. So this would be your 8 crore, 42,396. 15 crore, 3 lakh, 4,012 in words in Indian system of numeration by writing number in the place value. So simply you can write them. Determine the difference between the place values of two fives in this. So this is 500, this is 3 and 3. So 50 lakh you have to subtract it. So your answer will be 49,99,500. Now we have our exercise 1.2. Insert commas at the appropriate places and write the following numbers in words in the Indian system of numeration. So here we have 8 crore, 26, 8 crore. Our number is 8, 2, 6, 5, 4, 1, 9. Ones, tens, 100. After 100 we have 1,000, 10,000, 10,000 we have after 1 lakh and 10 lakh. So 82,000, 82 lakh 65,419 is our answer. After each period we have to put commas. So next we have 2, 1, 1, 7, 8, 1, 2, 1, 6. Ones, tens, 100. After 100, 1,000, 10,000, 1 lakh, and 10 lakh. After 10 lakh, we have crore and 10 crore. So 21 crore, 17, 21 crore, 17 lakh, 81,216. This is your answer. Okay. Next, 3 parts you have to give it a try and solve it as I do similarly. Next, follow the international system of numeration for each of the number in question number 1. Insert the commas at appropriate place and write the numbers in words. So let's take one more example for it in the international unit system. 8, 2, 6, 5, 4, 1, 9. So we have ones, tens, 100. After 100 we have 1,000, 10,000, 10,000, 100, and after 10,000, 100 we have 1 million. So 8,165,419 is your answer. Same you have to do for rest of the parts you have according to your international system of numeration. Next, write the following numbers in figures. 43 lakh. First we write 43 lakh. In 43 lakh we know we have 5 dash 14,000. 43 lakh 14,545. 29 million. So 29 million 73,000, 73,600. 600 is your answer. So similarly, you have to do the same process for rest of the parts you have. Next, move forward to question number 4. Write each of the following numbers in expanded notation. So first we write our numbers 7, 4, 9, 8, 3, 1. Here we have 10. Next we have, here we have 1, then we have 30, then 800, after 800 we have 9,000, after 9,000 we have 40,000, after 40,000 we have 7 lakh. In same way you can expand rest of the numbers you have. Okay, now move forward to question number 5. Write the numbers corresponding to each of the following. So in this we have 6,157, 3,098, 8 lakh, 8 lakh, 4,029. 8 lakh, wait. 8 lakh, 1, 2, 3, 4, 5, then 4,020, 4,029. This is the correct way to representing it. So rest of the parts you have to solve it your own as I do similarly. Now question number 7. Express the following numbers in words in the international system of numeration by writing the numbers in the place value chart. So you have to make it your own, your place value chart, but I'll give you a hint related to this. So this is your ones, tens, 100. After 100 we have 1000, then 10,000, and after 10,000 we have 10,000, 100. Okay, so it means this is 60, 200, 40, 60, 200, 4,178 is your answer. Okay, next we have to write, wait, 60, 200, 4,178. Similarly, you have to do the same process for rest of the parts you have in question number 7. Now we have question number 8. Write the place value of 6 in the following numbers. So in 6, ones, tens, 100, 1,000, 10,000. So 6 lakh. This is the place value for 6. Now ones, tens, 100, 1,000. So here we have 1,000 place value, 6,000. Okay. Now find the difference between the place value of 3 digits. So in 3 digits we have ones, tens, 100, which is 300. First 300, 100, 1,000, 10,000. After 10,000 we have lakh, 10 lakh, and crore. So here we have 3 multiplied by 8. ones, tens, 100,000, 10,000, lakh, and 10 lakh. So 3, 1, 2, 3, 4, 5, 6. Now we have to subtract 300 from this. 0, 0. Here we have 10, 9, 9, 9, 2, 7, 9, 9, 9. So your answer will be 29,97,700. Similarly, you have to do the place value of sum and difference as I do. Now, how many millions are there in 1 billion and 1 trillion? So you can easily answer because we already do international numeral system in our above section. After this, we have building numbers. In the previous section, you have learnt about place value and place value of a digit. Changing the position of digits in a number alters their place value and also changes the number. For example, in the number 295, the digit 5 has place value of 5, and the digit 9 has a place value of 90, and the digit 2 has place value of 200. Now, if we interchanging the position of 2 and 5, the number becomes 592, and the place value of 2 and 5 becomes 2 and 500 respectively. Thus, with the same set of digits, you can make different numerals by shifting the digits, as we already discussed it in our earlier section, that we have only 10 symbols in our Hindu-Arabic system, and by interchanging it, we can make a lot of numbers and a lot of different kind of numerals. So form all three digits numbers using the digit 3, 7, 8. Use the digit only once in a number. So these are those numbers which we can make by interchanging 3, 7, 8 several times. Using the digit 1, 2, 5, 6 and 9 once only from the greatest 5-digit number and the smallest 5-digit number. When you have a given number of set and you have to make a greatest number, always consider that you have to arrange your numbers in descending order 9, 6, 5, 2, 1. And when you have to make a smaller number, then you have to arrange your given number in descending ascending order 1, 2, 5, 6, 9. So then you simply make your smallest and greatest number from the greatest 4-digit number using two different digits. So you can easily make it. Now find the difference between greatest 5-digit number and the smallest 5-digit number. So this is your greatest 5-digit number 99,999 and smallest 5-digit number is 10,000. The difference between them is 89,999. Next, we have our exercise 1.3. Form all the 3-digit numbers using the given digits once only. So we have 2, 5, 9, 5, 2, 9. Wait. Make it simple for you. First, we have 2, 5, 9. Then 9, 5, 2. Okay. Then 5, 2, 9, then 9, 2, 5. After this, you can make 5, 9, 2 and 2, 9, 5. These are the numbers you can make from 2, 5, 9 by interchanging its places. Now, using the given digits once only, make the greatest and smallest 4-digit number. So, 5, 4, wait. 7, 5, 4, 2 is your greatest number and 2, 4, 5, 7 is the smallest number. So you can simply do your question number 1 and question number 2 as I do. Okay. Now we have question number 3. Form the greatest and the smallest 5-digit number using the given digits. You can repeat one of the digits. So you have 9, 5, 4, 2, the greatest number. After this, we have small number 2, 4, 5, 9. This is your smallest number. You can make all right. This is your answer. After this, make the greatest and the smallest 5-digit number with all the different digits such that 4 is in the tens place value and 9 is in the thousand place value and 6 is in the 100 place value and first in the. So make the greatest and smallest 5-digit number with all different digits such that. So 4's in the tens place value. First, we have to make a greatest number. So for this tens value, ones, tens, 100. Now place it at 4th place. Now you have to make it a greatest number. So you can ones, tens, 100, 1000. 4 9 would be at this place, and 6 this, and 1 here. So this is the greatest number we have by using this place value. After this, we have question number 5. How many numbers are there in all with 5-digit numbers? We have how many numbers are there in all with 5 numbers formed, and in 6 with 6 numbers. From the greatest and the smallest 5-digit number using 3 different digits. So this is a same example we have to do in our earlier section. So you can do that by following. So now following that, now we have large number in practice. You have learnt about centimeters as a unit of measurement of length. This unit is suitable to measure length of objects as a pencil, a book or an envelope, etc. But you have to measure thickness of cardboard, then you need a smaller unit. The smaller unit is millimeter. So 10 millimeter is equal to 1 centimeter, 100 centimeter is equal to 1 meter, and 1000 mm is equal to 1 millimeter. To measure distance kilometer to cities, a still bigger unit is required. The unit it's kilometer. So 1 kilometer is equal to 1000 meter, and 1 lakh centimeter, and 10 lakh millimeter. Now same for gram. So for weighing very light objects like chemicals and medicines, a small unit milligram is used. A bigger unit of weight is gram is used to measure weight of objects like jewelry, small quantities of species and spices, small quantities of spices, vegetables like lemons, ginger, etc. So 100 milligram is equal to 1 gram, 1 kg is equal to 100 gram, and 10 lakh milligram is equal to 1 kg. Similarly, pattern is there in the units for measuring quantities of liquid. The units are used milliliters, liters, and kiloliters. 1 kiloliter is equal to 1000 liter, and 10 lakh milliliter is equal to 1 kiloliter. A textile mill produced 4,768 meter of cloth in 2004 and 2,85,891 meter in 2005. 1,14,877 meter in 2006. What is the total production of cloth in the 3 years? So what you have to do, you have to add these 3 values together, okay, and by adding them your answer is 8,01,536 meter. A tablet contains 5 milligram of calcium. Find the weight of calcium in 12,000 such tablets. Express answer in grams. So we have milligrams and we have to express it in grams. So first of all, we have to find it. So for 5 milligram and 1200 such tablets, we have to multiply 12,000 by 5. Your answer is 60,000 milligram. Now we know that 1,000 milligram is equal to 1 gram. So we just simply divide it and you will get your answer, which we learnt here. 1000 milligram is equal to 1 gram, na? So it would be your 600,000. इसको यहाँ पे गलती है इनकी, बट मैं मेंशन नहीं कर रही हूँ. तो here you have your answer 60 gram. Now our men spent 17,50,000, 20,84,000 and 22,09,000 respectively on the marriages of his 3 children. Find the total amount spent by the men on 3 marriages. So you just have to add them together. You will get 60,43,000 is the total amount. Next we have exercise 1.4. A factory produced 3,35,477 soaps on Monday and 2,72,958 soaps on Tuesday. Find the total production of soaps on the 2 days. So we have to add them together. Nine, 12, 1, 13, 14, 1, 8, 10, 1. So your answer is 6,08,429 is the total production of soap in on the 2 days. Samir traveled 93,942 kilometers in a week and Rohit traveled 45,386 kilometers in a week. Who travel more and by how much? So now you have to find the difference between them. So 93,942 kilometer and 45,386 kilometer. We cannot minus 2. We cannot minus 6 from 2. So we have to take a carry. 12 minus 6 is 6. 3 we have to take a carry. 13 minus 8 is 5. 8 minus 3 is 5. 3 minus, so 13 minus 5 is 8. And 8 minus 4 is 4. So you have 48,556 more travel, and who? Sameer will travel 48,506 more as compared to Rohit. So in same way you have to solve rest of the questions you have, but take one more question. So a lift can carry a weight of 400 kg. How many books can the lift carry if the weight of each book is 2 kg, 250 gram? So first what we have to do? We have 400 kg load capacity of the lift, and each book weight is 2 kg and 250 gram. So this is totally up to us. We can change our numbers into gram, or we can change our quantity into kg. So let's do 2 kg will be equal to 2000 gram plus 250. So your answer will be 250. Wait. 2250 gram, or in this we can shift it, multiply by 4, to 4 multiply by 1000 to convert it into gram. Now we have 2250. 0 is cancelled out with 0. Okay, now here we have 4 5 8 0 9 1 and 330, 16. So 1600 upon 9, 3 5 नहीं हो पाएगा अगर मैं इसे चेंज करूं. So we have 400 kg weight capacity of the lift. So first we have to change it into gram. 400 multiplied by 1000. Then we have to divide it with 2250 gram. So while you solving it, you will get your answer 1600 upon 9. And by doing this, your 177.7 such 177.7 books can hold by the lift. Now Prachi walks around a park covering distance of 1 kilometer 265 meter. If she takes 2 such rounds every day, find the total distance covered by her in a week. If she takes 2 such rounds every day, so first we have to multiply it. So 265 multiplied by 2, 10, 1, 13, 1, 2 to the 4, 5, 30 and 2 kilometers. So this is the total distance by every day. Now we have to multiply it with 7. So 0, 7 3s are 21, 2, 7 5s are 35, 7, 3 and 7 2s are 14, 14 plus 3 17. So 17 kilometers, 710 meter is the total distance covered by Prachi. Okay. So students, this is the end of your exercise 1.4. Now we are going to do our next exercise in our next class. Till that, bye bye. Have a good day. Hello dear students, welcome back to your math classes. How are you all? I hope you all are doing well and healthy. So students, today we are going to start from our previous concept where we left our chapter 1.9 estimation. So in our previous class, in our last class, we done with exercise 1.4, and now we are going to learn about the estimation, and then we solve our further exercises. So estimating is an important part of mathematics and a very handy tool for our day-to-day activities involving amounts of money, lengths of time, distance and many other physical quantities. We come across many situations in our daily life where we need to have a rough idea of the numbers being used or considered expenditure for a party, time to cook a particular food, number of soaps need for month, etc. In the newspaper, you read headlines like 2,000 people killed due to landslides, 25,000 people watched the India-Pakistan cricket match, 150,000 people visited the holy shrine, etc. The numbers mentioned here are not exact numbers but only a rough estimate of the actual figures. If you are planning for a trip, you cannot pinpoint the exact expenditure. You have a rough idea before you carry out the plan. So what does mean and what you understand by reading this paragraph, that estimation is a random guess, right? For example, if around 10 to 15, like, right, I'm saying approximate, around, these kind of words are used in estimation, where we have not an exact value, but we determine a rough idea for that particular value. So at that time, the rough value which you are consider, and you take a random suggestion by the given situation, according to that, that is called your estimation. For example, if 25,000 people watch the India Pakistan cricket, it doesn't mean that we go there and count each and every person. It is a rough idea by the purchasing of the ticket, by the entries of people in the stadium. So that it's called your rough idea, approximate, which is not accurate value, which is very closer to that value. So now estimating to the nearest tens. To understand estimation, take three numbers, say 52, 57 and 59. Since you are estimating the nearest tens by reading the table of 10, you can make out that 52, 57 and 50 lie between 50 and 60. So we know that these three numbers, 52, 57 and 59, these three numbers lie between 50 to 60, right? These three numbers lie between 50 to 60. Now what you have to do, we have to estimate to the nearest 10. So it means the nearest 10 would be your 50 or 60. But how can we determine it? Okay, it could be 50 or 60. So for this, if we minus 52 minus 50, you will get 2. 60 minus 52 by 8, and so 52 is closer to 50. Similarly, you can check that 57 and 59 are closer to 60. So 52 is rounded off to 50, whereas 57 and 59 are rounded off to 60. So how can we understand that? How can we estimate to nearest 10? First of all, we have to check the numbers lie between, though first of all we have to write the numbers which they number lie between that. Now what we have to do, we have to see which number is closer to 50 or 60. And how can we determine it? By simply minusing it. So 52 minus 50, you have 2, and 60 minus 52, you have 8. So according to this, where you have small numbers, here we have small steps. For example, you can take an example for this. You want to buy a chocolate, okay, and there are two shops, 50 and 60. In this, for this shop, you just have to take 2 steps, and for this shop you have to take 8 steps. And you have a very high craving, so where you want to go? Obviously where you have few steps you have to take in. That's why 50 is the nearest of 52, and 57 and 59 are closer to 60. But what is going to happen if you have to round off of 55? As a convention, 55 is rounded off to 60. This is the rule for rounding off to the nearest 10. Now we have another example where they told us that now you want to buy a chocolate from shop 50 and from shop 60. Now in both the shops, you have equal numbers of steps, 5 and 5. Now they want to ask where you want to go to buy your chocolate, on 50 shop, on 60 shop. In that case, you always go to forward and you have to move towards 60 shop. This is your rule of estimation. If you, first of all, the first rule is where you have to take few steps, you have to move for that number, and if you have equal number of steps to move shop 50 or 60 or any other number, so then always move forward and go to the next 60 number, the next tens number you have. Now estimating to the nearest 100, the same rules are following here. Now the numbers we have, the numbers 51 to 99 are near to 100, then that to 0. So these numbers are taken as 100. The number 50 is midway between 0 and 100, is taken as 100. Thus, to estimate a number to the nearest 100, look at the digit at the tens place. If it is 0, 1, 2, 3 or 4, then digits are tens and ones place are replaced by 0. If the digit tens place is 5, 6, 7, 8, 9, then the digits and the tens and ones are replaced by zeros, and the digit at hundreds place is increased by 1. So what we understand here? Let's take an example. For example, 385 is estimation is 400, because 385 lie between 380 and 400. Okay, so in this case, the 5, this 5 because here we have tens 8 and 5 ones, so you have to shift towards 400. Next, 7251 is estimated as 7300. 6937 will estimated as 6900. So what we understand here, wait, first, to estimate a number to the nearest 100, look at the digit at the tens place. So tens place we have 8, right? If it is 0, 1, 2, 3 or 4, then the digits at tens and ones place are replaced by zeros. If you have these numbers 0, 1, 2, 3, 4, so that particular number will be replaced by 0. But here we have 8. So what are the rules for 8? Digits at tens and ones place are replaced by zeros if the digits at tens place is 5, 6, 7, 8, 9. So we have 8, right? Then the digit the tens and ones place are replaced by zeros. So tens and ones place are replaced by 0 and we replaced it, right? So now 7251, we have to check what number, which number. We have to check the tens place. So here we have 5. And what are the rules for 5? We have to shift 100 and tens and ones both with zeros. So tens and ones, we change it to the 0. Next, 6937. So here we check tens place, that is your 3. So according to that, if it's 0, 1, 2, 3, 1, 2, 3 or 4, then the digits at tens and ones place are replaced by zeros. So these numbers are replaced by zeros. Okay. Now we have our exercise 1.5, round off each of the following numbers to the nearest 10. So 83 will be nearest 10. 83 lie between 80 to 90, and to shift towards 80 we have to take few steps. That's why the round of 83 is 80. Now 7 is lie between, you can say, nearest 10. So the number is your 10 approximately, because we have to shift towards nearest 10, right? Now 39 is lie between 30 and 40, and 39 is more closer to 40 as compared to 30. The round off is 40. I hope so, student, this is clear to you, and now you can simply estimate your numbers. Round off each of the following numbers to the nearest 100. So nearest 100, how can we shift it? We have 27. So 27 will be, this will be lie between your tens place first, 20 and 30. So it would be your 30. This would be your 60. 544. Now you have to follow the rules we learnt in our above section. So 544, in tens place we have 4. Right? So according to that, your tens and ones place should be changed, should be replaced with 0. Right? One more example here. Next number is your 3786. Your tens place having 8, and according to 8, because we have, so if we have more than so now according to our rule, if we have 8 at tens place, it means your your tens and ones both are changed with which number? With zeros, and your 100 place, right? Digits at the tens and ones place are replaced by zeros, and the digit at 100 place is increased by 1. So 7 will be increased by 8, and your tens and your ones would be changed into and would be replaced with zeros, right? So according to that, you have to change it. So I hope so, student, this is clear to you. The two basic rules we have, which you have to follow in this. Next question we have, round off each of the following numbers to the nearest 1000. So 709 is lie between where? 700 or 800. So we have to shift it to the 800, or you can also say 710 is also the nearest number we have. Now 1295. So in this type of question, now where you have only 2 digits and you have to shift it to the nearest 100, so you can also say, you can take 100 also in that case. Okay. You can do similarly as I do earlier. Now we have question number 1295, and tens place, sorry, and 100 place we have 2. So the same process we have to apply here, which we see here, that estimating to the nearest 10, what we have to do? If the digit at the 100 place is 0, 1, 2, 3, 4, then the digits hundreds, tens, ones are replaced by 0. So in this case, hundreds we have 2. So we have to shift it to 00. So this is the your nearest 10. Next question we have. Let's take this one. 1,89,634. So in this case, your hundred place having 6. So according to your second rule, if the digits at the hundred place is 5, 6, 7, 8 or 9, then the digits at hundreds, tens and units place are replaced by zeros and the digits at thousand place is increased by 1. So 1, 8, 9, your wait. 1 lakh, 1 is increased, so it means 10 and it will be converted 9600. This is your estimation. Okay. Now round off each of the following numbers are the nearest 10, hundreds and thousands. So there is a combination of the nearest tens, hundreds and thousand. In this case, this is your thousand. Your hundred place is 2. So now you have to shift your thousand place increase by 1. So 7 increased by 1 is 8. Then 2 and 00 will be your answer. Right? So in here 76,000 and here it's you have 82,000. Now 14,561. So you can do that your own, students. Which are the greatest and the smallest number which rounded off to the nearest 100 give? So 100, 800 to the nearest 100 would be 800 is the smallest and 1000 is the greatest to the nearest 100. Write the greatest and smallest number which rounded out to the nearest 1000 give. So you have to answer it. Now we have next concept, estimating some difference product and quotient. Estimation can be used to get a quick and easy answer in situation where a precise answer is not necessary. So estimation we use where we don't need a precise answer, accurate answer. So you can have an idea about the possible answer without doing a lot of work. There are many situations where you need approximation. For example, when you go to market to buy a number of items, you need to have an estimate of the amount you need. This estimated amount is the approximate sum of prices of the things you want to buy. A man has 2 plots of land. He wants to sell both and with that money buy a bigger plot and invest the remaining amount in shares. He needs to have a rough idea of the total amount he will receive, the amount will spend and the amount he will invest. Since the amounts involved are running into lakhs, he rounds off the numbers involved to their nearest thousands and quickly gets an approximate answer. So in this type of question, when we have to estimate how much total amount would we have, so at that time you use your estimation. Let's take an example. Let us discuss some more example. Estimate the sum, that is your 237 plus 469 rounding off to 10. So 237 will be rounded off to 240 and 469 will be rounded off to 470. Now you have to add them together, so your answer is 710. Rounding off to 100 is 200 and 500. Here we round off to tens and here we round off to 100. So 700. Our actual answer is, when we add these two, so your answer is 706. So it means your answer is lie between these two numbers, 864 and 202. So 864 in tens we round off 860 and in hundreds we round off 900. 202 will be 200 and in this case also 200. When we add them together, so we have two numbers 660 and 700. So it means our actual answer will be lie between 660 and 700. So when we add them to, when we have a difference of it 860 and 200, so what we calculate here, 662 is our answer. Okay, so in the first example, both the estimates are pretty close to the actual answer, but the second example shows how far off you can be from the actual answer. 700 is nowhere near the actual answer 662, but in both the examples you can observe that rounding to a lesser place is more precise. There are no hard and fast rules to estimate sum, difference, product or quotient of numbers. The number involved in calculation are rounded off and then the required operation, addition, subtraction, multiplication or division is performed. The place to which numbers are rounded off depends on the situation, the degree of accuracy required, simplicity of computation, sensibility of the estimated and the reason for which estimate is required. For example, your mother, not your mother, because that is a big amount. Okay, fine. For example, there is a party and the manager is assuming a number that there would be around 662 people would be coming. But in suppose case, a second manager take a round of this part, 900 minus 200, the rounded off towards the 100. So what will happen? 700 is so far away from 662, whereas manager A is estimate according to tens and get the 660. It means that it's closer to 662. So what we have to understand here, that the estimation is always dependent upon your situation, upon your how much which kind of situation you have, how you have to estimate, and simplicity of computation. So these are the things and these are the reasons we have to consider in our mind while we estimating any number. And always consider that you have to estimate in that way that your actual value, that way that your actual value will be closer to it. The second thing we have, after estimation, then we have to apply our operations like subtraction, addition, multiplication or division. Now we have example number 1. Estimate the sum of 7,320 and 15,961 by rounding off the numbers to their nearest. So here we have hundreds and thousand where we have to shift it. So 7,320 will be rounded to 700 because 7,300, because in this case we have to ones place 3, and when we have ones place 10, 100 place 3, so it means we have to shift towards, we have to change our tens and ones and replace it with 0. In this process have we 9, so it means we have to increase our thousand place by 1. So here we have 16,000. By adding them together, we have our answer 23,300. Rounding off the given numbers to their nearest thousands, we get 7,000 and 16,000. So estimated sum. So the 7,000 and 16,000 is equal to 23,000. Okay, students. So now estimate the difference, 4,851 minus 249. Rounding of the given numbers to their nearest thousands, we get 5,000 and 0. Estimated difference would be 5,000 minus 0 is because rounding off to numbers to the nearest thousand. So here we have not nearest thousand, so we have to write 0. And in this case, if we shift to 2, so what we have 5,000. So 5,000. You can see that this answer is observed at is greater than 4,851. Actual difference between the two numbers are 4,602. Let us round off the numbers to the nearest hundreds and we get 4,900 and 200, while we have a difference of it. So the answer is 4,700. This is a better and reasonable estimate as it is closer to the actual difference. If we have a situation where we have to shift it towards the thousand, so it doesn't mean we have always a correct answer. You have to see the situation, you have to identify what kind of estimation you have to apply according to tens, according to hundreds, according to thousand. After guessing or after identifying exactly your situation, then you have to solve and then you have to put your estimation. If you don't apply these things on your estimation, then you will get such a kind of answer which is not relatable to your accurate answer. Now we have estimate the product of 81, 89 and 21. So 89 round off will be 90 and 21 round off will be 20. While we multiplying it, so we have 1800. Product is 1869. So it is a reasonable answer we have. Same process for 375 multiplied by 62. So 375 will be shifted to the 400 and 62 will be shifted to the 100. So your answer is 40,000, but your actual answer is 23,250, which is far away from 40,000. So now you have to take another round off. You can see that the estimated product 40,000 is far off from the actual answer. Rounding off the given numbers to the nearest tens, we get the estimated product 380 multiplied by 60 to 22,800. So that is closer to your answer. So now you can relate and now you can easily understand how you have to estimate your numbers. Estimate each of the following by rounding off the numbers to the nearest 100. So 419 will be shifted to 420 and 196. So here we have tens place 200. So while we adding them, we have 0, 2, 6. Here we take actual addition of it, 419, 196, 5, 1, 10, 1, 11, 1, 5, 6. So that is more closer to your answer, 615 and 620. It means you're doing correct. Next question, you have to do it your own. We shifted to the question number 2. Estimate each of the following by rounding off the numbers to the nearest 1000. So here we have 5241. Hundreds place we have 2. So we have to shift our number 5200. Then we have to add this. So it means 800. So by adding 5, 7, 12,000 and 13,000, so your answer is 13,000. Let's take actual addition of these numbers. 5,241, 6,885, 6, 12, 1, 10, 1, 11 and 12. So that is more accurate to your, but not little that much accurate. If you shift it towards your tens place, then it could be more accurate. So here is your answer. That is not that much reasonable answer. Okay. Now for rest of the following you have to estimate. Now estimate each of the following by rounding off each number to its greatest place. So 4,496 will be converted into 4,500 and 745. So we have 4, right? So we have to shift it towards 700 or 740, we can say that. 4,500 and 740. By adding them together, 0, 4, 12, 1, 11 and 12. So this is your answer, 12,200. No, how is it possible? Now we have to add them together. So 4,500, 740, 0, 4, 12, 1, 5. So 5,240 is your answer. By first we do actual calculation for it. 11, 1, 13, 14, 1, 11, 12, 1, 5. So your answer is more accurate to your answer. If you want now, so you can take also here 50, right? By taking 50 here, your answer will be 5,250, which is greater to it. So you have to think according to your situation and then you can simply apply these rules. Find a rough estimate of each of the following by rounding off each digit to its greatest place. Also, oh wait, let's take one more question where we have to do multiplication. 925 will be shifted to 900. Multiply 76 will be shifted to 80. So 9 8s are 72 and we have 3 zeros. Now we do actual calculation. 9, 2, 5 multiply by 76. 6 5s are 33. 6 2s are 12, 15, 1, 6 9s are 54 and no 54 and 54 plus 1 is 55. 0, 7 5s are 35, 3, 7 2s are 14, 7, 1 and 9, 7 9s are 63, 1, 64. So we have 0, 10, 1, 12, 13, 1, 10, 1, 7. That is closer to your answer, 70,300 and 72,000. So you can also multiply it with 75, that your answer will be more accurate, but that is also reasonable. So accordingly, you have to solve rest of the questions you have in question number 3. Now find a rough estimate of each of the following by rounding off each digit to its greatest place. Also find closure estimates by rounding of each number to its nearest 10. So here we have our number 7,285. At hundreds place we have 2. So we shifted to 7,200 plus 198 will be shifted to 200. 2 2s are 4, 2 7s are 14 and your answer is this. Oh wait, we have to add. So 0, 0, 2 plus 2, 4 and 7. So your answer is 7,400. Let's take actual calculation for it. It is closure or not. 198, 13, 1, 16, 17, 18, 1, 4, 7. So your answer is closure to your estimation. Accordingly, you have to solve rest of the parts you just have to estimate, and then you have to apply your operation. A machine on average manufactures 3725 screws per day. Approximately how many screws did it produce in the month of August? So you have to multiply this number by estimating. In August we have 31 days, so you just have to multiply it. So your answer will be 4000, because in 100 place we have 7, which is greater than, right, 5. So we have to shift it 4000 round off, and it you have to multiply with 31, and you will get your answer, which is 4, and 4 3s are 12. So 12,000, 1,24,000 is approximate your screws did it produce in a month of August. Now we shift to our next number, Roman numbers. Recall that the numeral 0, 1, 2, 3, 4, 5, 7, 6, 8, 9 are Hindu-Arabic numerals. Another system of writing numerals is the system of Roman numbers, which is originated in ancient Rome. The system is based on a certain letters which are given values as numerals. So these are your numeral numbers. We're representing it. I means 1, V means 5, X means 10, L means 50, C means 100, G means 500, and M means 1000. Ans, quinque, decim, quinquaginta, centum, quingenti, and milli. So these are the terms we use for translating our numbers into Roman numbers. Multiple symbols be combined to produce numbers in between these values object to certain rules. While we have to change our numbers into Roman numbers, we have to follow these rules. So let's learn this. The easiest way to note down a number is to make that many marks I. This I denotes 1, and second denotes 2, third denotes 3. However, 4 strokes seem like too many. Okay, so you can represent it till 4 strokes. Okay, so the Roman move on to the symbol 5, meaning 5 placing 1. So this is your representation of 1. For representing 1, 2, 3, 4, you can use this 1. So for 1, we have to write this only one time. For 2, you can write it 2 times. For 3, you can write it 3 times. And for 4, you can write it 4 times. Okay, you can also 4 times. After this, what you have, however, 4 strokes seem like too many. You just have to represent it till 3, because 4 it's confusing in Roman numbers. So till 3 you can use your 1. After this, so the Roman move on to the symbol V, meaning 5, placing I in front of V. In fact, placing any symbol smaller in value in front of any symbol of larger value indicates subtraction. So this, if you shift 5 is greater than as compared to 1, if your smaller numbers towards right hand side, it means you have to do subtraction. So 5 minus 1 is 4. If your smaller number towards left hand side, it means you have to add. So 5 plus 1 is equal to 6. Okay, students. Next, the number 10 is represented by X, but wait, what about 9? The symbol 9 stands for this. This symbol stands for 9. Similarly, if 10 is this. If I representing 1 towards right hand side, it means I have to subtract it. So 10 minus 1 is equal to 9. Now, so triple x 1 is 31 and triple x I 5 is 24. How? We have 20. In 20 we have 4. So 24 is our answer. Next, if a smaller numeral is placed between two larger numbers, it is always subtracted from the larger numeral placed to its right. L means 50. Based on what you have learnt, you can make out 40 is right. You can make 40. 40 is represented by XL because X is smaller as compared to L. L is your 50. So 50 minus 10 is your 40. Now you can also make 50. How can you make 50, 60, 70? LX is 60. L XX is 70, L triple X is 80. C stands for centum, the Latin word for 100. The subtraction rule means 90 is written as XC, means 100 minus 10. Like the X and the C's are tagged on the beginning of the numbers to indicate how many hundreds are there. So CCCLX 1X is 369. CC means 3 times 100. So it is 300. After x is 10. But what we see here, we have left side. Okay, fine. So we have to, if we have smaller number, we have a smaller number between two numbers. So this is 10, and after 10 we have 9, and here we have 50 as well. So this is your 69. 300 plus 69 is 369. D stands for 500. You can probably guess by now. CD means 400 because D means 500 and C means 100. So you can subtract it and you will get your answer. So similarly, you have to solve your questions by following these rules. Large numbers are indicated by putting a horizontal bar over a numeral, which means that numeral is multiplied by 1000. V means 5000. The symbols V, L, D are never written to the left of a symbol greater value. V, L, D are never subtracted. The symbol I can be subtracted from V and X only. I can only subtracted from V and X. The symbol X can be subtracted from L, C, M only, not D. Only L, C and M. The symbol C can be subtracted from D and M only. So I hope so these rules are clear to you. Now write Roman numerals for the following. So 22, how can we write it? 10 and 10, 20, and plus 2, 1, we have 22. 49 XL plus 9, this is your 49. 76 L, 50, 10 and 10, so 70, and this is your 6. So in such a way you can represent your numbers. Write the following in Hindu Arabic numerals. So this 20 and this is 6, so this is 26. 50, 20 and 3, so 50 plus 20 plus 3 is 73. 10 C, so C means this is your 10 and C. C is 100 and 100 minus 10 is 90. This is V and this is 3. So 98 is your total answer. Now we move forward to our exercise where we have to write Roman numerals for each of the following. So this is your 45. So 10, 10, 10, 10. 40 and for 5 you can represent like this. For 69 you can take for 69 wait. For 69 we have L plus 10 and L, wait, LX plus LX. Now we have to represent 9. So this is your 9. This would be your 69. For 88, so we have to represent first 100, which is your C. Now we have to subtract from C. How many numbers we have to subtract? 90 and 90 plus 2. So how can we represent 2? 10, C and 2. थोड़ा सा गलत हो गया, चलो दो ही समझा देती हूँ. So this is your representation for 45 and 69. So similarly you have to represent your rest of the numbers in question number 1. Now write Hindu Arabic numerals for each of the following. So here we have 10, 10, 10, 30, 30 plus 2, 32. L means 50, X, X, X. So 50, 30 and 9. So 50, 30, 80, 80 plus 9, 89 is your answer. After this we have C, L, I, V. So C it's from, so it means 100 minus 50 plus 4. 54 is your answer. So in same way you have to do rest of the questions you have in question number 2. You just have to write the Hindu Arabic numeral. After this, these are the things you have to keep in your mind for solving your chapters. In suppose case you forget any points, so what you have to do, you have to recall these points and you can identify what are the concepts you learnt in this chapter. So students, this is the end of your chapter. I hope so it is clear to you. Now I'm going to meet you in your next class. Till that, bye bye. Have a good day.